and welcome back. I'm going to proceed with the workshop automation project that I'm working on. Not necessarily confined to workshop, of course. Could apply to a house, most probably is in many cases. But I just wanted to do a very quick comparison, if that's the right word, between the Sonoff 4-channel and the ESP826601 relay that we were playing about with, I don't know, a few videos back now, back in, I think it was video 107. I know that immediately after that I did a very quick video showing how I'd changed the code for the ESP8201, and I've got a phone app as well, which looks amazingly like this. As you can see, it's a pretty simple thing. It just goes to a particular IP address and turns something on or off. But as I said, I did that videoing a little while ago now, so I'll just drop it in here. I can't quite remember what exactly I did, but I know I showed a proper demo. Just put that phone away. Now, inside this Sonoff, there is an ESP8266, so it's not a million miles away from what this is, except that this was, quite frankly, pretty poor. It was an unfinished product, wasn't it? So I've changed that, changed the code that's running on here, and you just saw the phone app. So together, they now work pretty much as I'd expect, except for one little thing, which I'll tell you after that drop-in video. And then we can have a look at this Sonoff 4 channel, and as you can just about see, the red's on there, which means channel outlet 4 is on, R4. If you remember, there's always a terrible problem in filming LEDs. Now, I've only just got this going actually. It requires an app on my phone. It also requires an app to link it into the Amazon Echo. But all in all, it works. I mean, you can press these buttons here to make things work. So if I press number 2, click on it goes, and click off it goes. But I can also say things like, watch that top light there. Alexa, turn on workshop heating.
Sorry, I didn't find workshop heating.
Okay, that didn't work the way I expected it. What did I call it? I'm sure I called it workshop heating, didn't I? Let's have a look. I'll show you why I'm doing this. Oh yeah, that's right. Cool. Alexa, turn on workshop heater. Oh,
okay.
There we are. A little bit of a delay there, but it's on. And she did say okay. Now this one here, I haven't renamed any of the others. These are still outlets 1 to outlets 2, 3 and 4. So let's see if we can turn this one off without any jiggery pokery. Alexa, turn off workshop outlet 4.
Okay.
Hurrah! So there we are. So this is linked up in a matter of minutes really to both the Amazon Echo and my phone. There's a phone app not a million miles away from what you just saw, actually, the one I wrote. A little bit more sophisticated obviously, but that's just coding, isn't it? Or as they say at work, just typing. But how do these compare? Right, first things first, let's look at the video that explains how these ESP8266 01s are now configured. There's something about that one I want to talk about. That one I don't. That one just a little bit, and then we can talk a bit more about this and see what steps I've made towards that nirvana of workshop automation. Now this is a quick update to the ESP826601 Wi-Fi relay that we did however many videos ago was now. That was video number 107, and if you watch that you may have seen that this device here, which is an ESP01, you can probably recognise it from that, was plugged into this board down here. And once again I've forgotten my little pointer, so let's sort that out first. So that plugs into here. Where you see this green cable go in, there's a 4-way socket, sorry, an 8-way socket there. So that ESP01 device plugs in there, and it's supposed to turn off this relay, well, on and off hopefully, via the Wi-Fi, your Wi-Fi and a phone like this one here. And it brought a whole new meaning to the word faffing about, because although it required some AT commands initially to set it up, which was okay, a little bit faffy, but once you set it up it sort of worked okay. And the app that I don't know if it was Espressif that actually provided the app, must have been, that also was a little bit faffy, but it was okay. It would have been usable. But what happened was, as soon as you powered that device down, the ESP8266, it forgot a couple of crucial settings, which made it a bit useless, really, didn't it? So what I did in that video was just quickly hook up an Arduino to supply those commands again when there was a power failure. But as I say, it brought a whole new meaning to the word faffing about, and you couldn't ever really implement that as a production solution. Production in your home, I don't mean industrial production, producing them by the million. But the main issue then was that it was just too complex. It was rubbish. As I said, even in the video, what we really need to do is reprogram the ESP8266, put our own code on there, and then presumably, because we've got our own code, we probably want our own phone app. Lo and behold, as you can see here, that dinging you can hear is because I've just dislodged a cable, and you can see it's flashing in time with this. So I better sort that. That is in fact the problem with this now. This whole setup, it's so fragile with so many wires going everywhere that you end up with this sort of mess, which we cannot continue. And I have a solution for that too. So let me get this sorted out and I'll just quickly come back to it. Right, we're back, and we're connecting to my Wi-Fi again. That's working okay. Now, as you can see at the moment, the LED back here is not on, and neither is the relay. But if we push this button here, let me get that on, and that one isn't, because that's the one I forgot to connect up again. So what I mean about faffing about, we couldn't possibly develop like this for real. Right, so that's on as well, and if I press the other one here, they're off. Press it again, they're on. And in fact, let me show you a little window. I'm just running putty. I'll put links to everything I mentioned here at the bottom of the video. But let's have a look at putty. So this is what putty's looking like, and it's just a serial monitor, just the same as it would be for the Arduino IDE, but I don't want to fire up the Arduino IDE at this moment. I've had this running just before I disconnected it all for the video here for a good 24 hours, and it's been stable as anything. Now, as you can see at the moment, it's printing these dots. This is all programmed into the sketch, by the way, that I concocted, so I can show you all that later. But if I press off now, you'll see that it will connect. There it goes, quite quick, wasn't it? So it says connected. First of all, it's then waiting for some data that is on or off. Then it tells you what it read, and it read this bit here. And from that, it can work out that the last bit is 0, so it wants to set it to low. If I press the other one, you'll see that this bit here actually goes to 1. There we are. Now, you could actually type in anything here, because this is just part of the URL that you're sending through as part of the get command. It's not a post, so you do actually see it in the URL. It's not particularly secure. It's only HTTP, but for proof of concept, I think this is fine. But the biggest problem now, all these wires and everything, this is all right for a quick lash up. There's the ESP8266, there's an FTDI USB to serial converter, which you need to program this. Some people I know use Arduinos or something to program these, but I never have. So that's what you need if you haven't got anything else. The wiring here looks a mess, but it's not. It is straightforward and logical. You only need 4 wires from the USB to serial converter, but you do need, well, all 8 wires actually. No, 7, tell a lie, 7 from here to sort of talk back to here and back to the computer and do all this kind of stuff. But this is never going to work properly, so what we're going to use is one of these. Now this is something where the ESP plugs into this, so all these wires disappear. Okay, and there's even a little switch on the side there to say, am I programming the ESP or am I reading it? Okay, oh, wrong way around, look, you can see it on there. Programs that way, and that way it's serial in and out. I've not actually used this before, because I don't think I've ever programmed an ESP8266-01. I've used the ESP8266-13 and possibly even a 12, but not an 01, which is why I've never used this. But now's the time to put all these wires into bed, plug this device directly into here and make sure that all this still hangs together. At least we know we've got a working solution though. So if anything goes wrong, it's well, this setup really, rather than anything else. But it's a fairly simple one. Doesn't use MQTT or anything like that. It's just a basic URL RESTful state, I guess you'd call it. So let's get this sorted out, and then we'll come back to the sketch and everything else. And here's a nice clean desktop now. Just the phone app and this little device here that you plugged that ESP8266 in. Now there is one or two flies in the ointment actually at this point. First of all, I didn't film this bit, would you believe, before I came into the workshop. So I obviously filmed the first two bits thinking, oh yes, I must absolutely do that before I move workshop, and then well, ran out of time, I guess. So I was thinking I was just going to edit my video together and just go, but I have got a missing bit of it. So this is it, filmed now in my workshop. But we're going to make it quick because I do really want to get onto that 4-channel Sonoff. So here's the device, nice and neat. There's the switch. It's currently set to UART. And if you look at this here, there's no LEDs on here that we can use, like the built-in LED we can on an Arduino, for example. So there's nothing going to happen on here. But if I press the, what does it say? GPIO is now low. So if I press the on button, it goes high, press the off, and it goes low. So at least we can tell it's working here, more or less. Ideally, what we would have liked, if I go to the code window, is something to appear in this bit here. So it says connected to serial port 6, which is what I'm on, a baud rate of 9600, and nada. I don't know why it's not showing the same information that you just saw in the video on the PuTTY screen. I've tried PuTTY as well, nothing. And I've looked at my code here and I haven't changed the code. This is the code that I wrote, and I don't know why, but frankly I'm not going to spend any more time trying to sort that out because it's just not a priority at this time. I'm sure you're probably eager to get on as well. However, if you're interested in the sketch, how we get this to work on here, this is it. This is the sketch, and I'll put this sketch up on the video description. It'll probably be my GitHub like most times, so there'll be a link there for that. It's all pretty explanatory. We set it up, assign it to the Wi-Fi, and well, then we just wait for things to come in. I do of course print that dot here like you saw, and if only we could see it over here, and that's it. Okay, so I'm not even going to go through that. This is all documented, so it should be pretty much self-explanatory. So that's the code that's running on here, and this sketch, no, it's not a sketch, is it? It's I don't know what they call them actually on the MIT App Inventors. This program that's running on my phone, I'll put a link up. Well, no, in fact, I'm going to have to export my project from the MIT App Inventor 2 and put that up there as well, and then you can go to the MIT App Inventor 2 and import that project, and you will have exactly this. Okay, so no problems there. I know that a couple of people have mentioned to me they've tried to search for me on that website and can't find my stuff. I'm afraid I don't know why you can't find it. I haven't said anything to say it's private or anything. I don't know. Technology sometimes does get the better of us, doesn't it? But I don't want to spend too much time, well, faffing about. I think we've had enough of that, haven't we? Right, so that's that then, and well, you can see how nice and neat this is. And that switch, let me just go back to desktop mode. That switch is currently set to UART, which, if only it was working as we'd expected, you'd now see all that stuff on the debug window or the serial monitor window coming out of it. And then when you want to program it from, well, I'm doing it from the Eclipse IDE, but if you want to do it from Arduino IDE, just the same, you'd simply switch that over. You do have to unplug and plug back in again, and what that does, it holds the ESP8266 in a sort of well, a programmable mode really. It brings the I think it brings GPIO 0 to, does it bring it to ground? I'm pretty sure it does, and I don't know, there's something else as well, and that's how it sets it into programming mode. That's it. That's all I can tell you about that really. if I haven't gone into enough detail with this, if you think, oh, if only had told us a bit more about this, that and the other, drop me a line. I'll try and flesh out a little more detail. Let me show you where I got this from. Now, I bought this from a British eBay supplier. This one here, Happy Butter Trading, he's called, and it was £4.79, which I suppose in the scheme of things is quite expensive, isn't it? But the reason I bought it from him, I assume it's a him, could be a her, who knows, is because this was the only one, or one of the very, yes, no, I think it was the only one that had this little switch thing on the side to say, you know, switch it from one mode to another, you know, programming or UART. The main issue with this I have is that they haven't extended these header pins beyond this unit so that you can't plug stuff on. What I'd really like to do is to basically take this header off and put some extendable ones in, so you could then attach DuPont cables to them, so we could see what's happening when it says low and high. We can attach it to a breadboard with an LED. So there's room for improvement on here. Actually, it's not this bit that's changed, it's this bit, isn't it? Those pins could have come out. Anyway, that's nothing that's going to change by me saying that. Now, there is another item I bought, and let me just see where that one is. That's yes, that's this one here. Now, this is similar in concept in as much that you plug your ESP into it in pretty much the same way. So that goes on the top. Oh, no, I don't want to muddle these up. Let me put that way over there. Right, so that goes in at the top, but as you can see, it's using DuPont cables to connect up to whatever you want, really. And the idea is that, well, this exposes, what does it expose? A couple of pins on there, ground and VCC, which you can use to power it. And it's just a bit neater, isn't it? And all that rat's nest of stuff that I had. So this will go onto your breadboard or wherever. Okay, these are female. It probably needs to have male DuPont cables to plug into a breadboard, but you get the idea. But as it happened, I tried this out and found it a little bit cumbersome once again with all the cables. So I went with this one instead, and that worked really well while I was doing it. I've got to admit, it worked really well. So I don't know why we're not getting that serial information out at the moment, but not to worry. Right, I think at this point we'll put this to bed and we'll go back to the rest of the video that I have. I know I have videos ahead of time, and just see, well, forget the programmer now, just see how this stands up a little bit and what we could have done to improve that relay. Not this, where is it? Not this one, this is the one I'm going to show you, which should have been the answer. Well, the one that we were using and I've had to hack a little bit, how could that have been improved, and is this the answer? Let's go back and find out. And there we have it. So this one sort of works now the way we want it to work, even though it required this sort of ugly hack with a resistor and using GPIO2 rather than the serial ports. What we could really do is a simplified form of this one. Okay, so if I take that ESP module out, so as you can see, there's a lot of components here. In fact, there's fewer than they were because I've desoldered them. There was some kind of well, I think it's some sort of microcontroller on here, but unfortunately I blew it up because I applied too many volts to the input and I didn't want it anyway, so there we are, it's gone now. But really what we wanted, if we're going to use an ESP8266 like this, right, which you can just put your own little code on, all you want on here is a transistor and that relay, and that's enough. Alright, I mean, yeah, a couple of resistors and protection diodes and things, but apart from that, that's all you want. A transistor to turn that off, which is effectively what we're doing, isn't it? By doing this, we're putting GPIO2 through this resistor, which on that little thing there, that is a transistor, and that transistor there turns on that relay. That's the protection diode, in case you were wondering, and that's it. If only there was a board that was a little bit simpler than this, it would make a lot of... Oh, what's that one? Oh, look what I've found. I found a much simpler board. Look at this. Now this is pretty much like that in concept. It's got room for the ESP8266 to plug in, and all it's got on it now is a voltage regulator, one transistor, the relay, and a protection diode, and that's it. Oh, and a reset button, which the other one didn't. The other one didn't have actually. So hey, have we found the simplest thing we could have for an ESP8266? Just plug that in and see how it goes. Let's do that next. So here we have the device plugged in, pretty much like it was before. If I press on, it all came on. You probably heard a click. Let me do that without my fingers in the way. We can turn off. See, so it all works as you'd expect. So have we found a simple unit that allows us to use it as we might expect? No, we bloody well haven't. What are all these resistors doing on the bottom, you may well ask? Why is it we can't get some blasted piece of equipment from China that works the first time round? Why have I had to do these hacks? Why are the pins not connected up so it works out the box? I tell you, if there's no... Sorry about that, there was a technical interruption there. As I was saying, we had to amend slightly the hardware configuration of this unit to enable it to work. Basically, the CHPD pin was not being brought high, so it wouldn't run, and GPIO pin 0 has got to be brought high in order for it to run initially from the bootloader. You only want to bring it low if you want to boot thing, if you want to put new code on here, which we most certainly don't at the moment. So neither of that was done. So unfortunately, we did have a misconfiguration there, a suboptimal configuration. In other words, it wouldn't bloody well work. So I've had to make it work. So basically, this is as rubbish as that other item was. Calm down, calm down. And a deep breath. So it's a little bit disheartening, isn't it, to find these units being shipped out from China purporting to do something that basically they just can't do, not without a lot of hacks. Now, okay, a lot of hacks. There were 2 resistors I had to put on, and would you believe, when I created this for the other unit, wherever it's gone, that one, I thought, right, which GPIO pin am I going to use for my output? I know that GPIO 0 is used as part of the booting up process or uploading code, so let's steer clear of that. Let's use GPIO 2. What do they use on here? Yeah, you've guessed it, GPIO 0. No, they haven't used 2, have they? It's just gone to total waste. So in fact, what one of these resistors is doing is connecting up GPIO 2 to GPIO 0 just to get the voltage across, because I wasn't prepared to reflash this. So having done that, it now works, as you briefly saw, exactly as you'd expect, on, off. Now you might argue, hacks notwithstanding, that in fact this bit of code running on here and this is more than enough to turn my heater on, and I'd agree, it is. It doesn't tell me the temperature, of course. This isn't sending out the temperature, and you could use GPIO 0 as an input if only we weren't using it as an output as well. Duh. What kind of design decision was that, I wonder? So really, this isn't good enough. And Benny, who you can see over my right shoulder there, totally agrees. In fact, he was talking to me about this just beforehand, and he says, this fit for the bin, he says, no good whatsoever other than the simple remote on-off switch, the likes of which you can buy from any hardware store and do-it-yourself store and Amazon and places like that come with a nice pre-molded plug, and you just plug them in, plug your appliance into it, and have a little 433 megahertz remote controller, because it's only as good as that. So what do we do this? Chuck it. Useless. This is quite nice. I'll put this code up. It's written with the App Inventor, MIT App Inventor 2. It's all sort of jigsaw puzzle blocks you move together. I've used it before for the Bluetooth one, which was on that in that video that you're seeing on screen now. But that's, I think, where this whole saga of this and all this stuff here stops, quite frankly, because I've had enough. Even if these had worked absolutely out the box without any mucking about, they're still not intelligent enough, are they, to do much, which is why we come back to the Sonoff, which is marginally more intelligent and certainly a lot more capable than any of this, and also comes with its there we are, that's that one, there we are, that comes with the phone thing as well. There's my heater and outlet 2, 3 and 4, and of course it does connect into the Amazon Echo. Brilliant. Let's power this one up again and talk a bit more about that then. So we're just sort of booting up there. You just managed to see that light flash there. That means it's connected into my Wi-Fi. It was a 2-second job to connect it up, and there's plenty of instructions to go along with it. Oh, Benny's found that relay that we didn't like, and he's chewing on it. Right, okay. So you've seen the Amazon Echo bit, turn it on and off. This is the phone app, which is, as I say, not a million miles away from what that other one I wrote, just looks a bit nicer. So I can say turn my heater on and off from here, click, and I was thinking about it, perhaps because we disconnected it, there we are, click, off it went. Okay, that red one. And now I've configured this, I'll explain all this in a minute, so that when you turn these things on, you can turn them all on or all off, or as many on or off as you want without them toggling others off, because that's how it comes out of the box, which is a little bit silly really. And also there's a massive delay between pressing the button, something happening here, and then toggling the other one off. It will set something like 4 seconds. Very strange. I'll talk about that in a bit more detail though when we look at this as part of the workshop automation project. So just to prove this is still working, that R1 at the top, outlet number 1, we'll just make sure that you know who can still control that. Alexa, turn workshop heater off.
Okay.
Okay, indeed. There we are. So that's working. So that's a good first step. And the Amazon Echo bit is just a sort of a nice to have really, because after all I am here in the workshop. I don't really need to have that facility. I can just get up off my chair, burn a quarter of a calorie, walk into the heater there and switching something on or off. But of course that is not the way we do things in Arduino and Pyland. So let's think about and draw up a little bit what's going to happen next. Right, as a wind up then to this video, let's see what remains then for the next steps. First things, let me just talk to you about how I've had to change the configuration for this unit. When it turns up, it's set to some, well, unintuitive mode really. So what I've had to do is first of all change this switch here, switch 6 that is. Now in fact if you take this out of the box, and once you've removed the 4 screws, the whole thing comes out quite nicely. And obviously I've not got mains connected. Please do not connect mains. These are volt free contacts, so unless you choose to put something in here and then connect them to each one of these to switch, they remain volt free, which means you can use it to switch 5 volts if you want, or indeed 0 volts, bring something to ground. Thanks to Gavin, one of the followers, who alerted me to that. That's brilliant. So on the back here, if I can get it close enough, it says switch 6, that one here, it was set to 0, which meant interlock. Now I didn't want interlock, I wanted self-locking. That is, once you've turned a switch on, I wanted it to stay on. So that was the first thing I had to change. And by 1, what it means is, I'm going to just unplug this now while we're doing this, get the wire out of the way. So on switch 6 here, which is now upside down, so on switch 6 I had to put it to 1, as you can see here, not 0 where it was where it first came in. In the K5 work mode, it's inching or self-locking. Now inching is a strange term to use for these. Inching and jogging, they're, to me anyway, they're terms that you might use, say, with a, well, like some sort of motor. You can jog it, that is to say apply a short burst of power to it, just to sort of, you know, I don't know, winch up a little bit more perhaps. And inching is where you do the same, you apply short bursts of power but a reduced power, so it's a little tiny bit just to get that last, well, as the name implies, you inch along a little bit. But inching on here means something totally different. It means some kind of delay system. We'll come on to that in a sec. So anyway, I'll switch it from inching to self-locking, which means once you've switched something on, it stays on until you switch it off. Doesn't matter what you do with the rest of the switches, that one stays on or off. And ditto on K6, these were all set to, what were they set to? Ones, I think. Do you know, I can't remember. What's it set to now? Let's have a look. K6, it's these little tiny ones here. Oh yes, and the reason I left these little bits of yellow on the back plate here is to remind me that these were in fact covered in a little tiny square of that stuff, almost as though they didn't want you touching them, but it's not true. I mean, that's for configuration. Maybe they're just protection or something. Anyway, you have to peel those off, those little bits, so you can get hold of these. Now, if we come in close as I dare, yeah, K5 and K6 are all set to 1s now. So if we go back, so if they were set to 1s, they previously were set to 0s, which means there was a 16-second delay applying to all 4 channels when you switched over. So what did that mean? That meant, let's take an example, channel 1 was on, you press channel 2, that would go on, and then either channel 1 or channel 2 would go off after 16 seconds. Whatever, it was all very confusing. Anyway, so they're all set to 1s now, which means there's a 1 second delay time switch, except that I don't even know if that applies anymore. Now we've set this to self-locking, but certainly intuitively I expected this to work as it does now. So move that switch there over to the left, set all these up to 1s, and now what happens is on the phone app, and if you use these, just these buttons here, just to press them on and off manually, what happens here is, as you can see, you can switch any one of these switches on or off totally independently. It doesn't affect the others. So whereas when it arrived, if you switched one of them on and then you switched another one on, after a bit that one goes off, and then you switch that one on and after a bit that one went off. It's all a bit odd, as I say, but configured like that, it works exactly as I would expect it. In fact, if anybody out there has already got one of these or something similar, perhaps you could explain what this setup was designed for, where things switch off like that after a predetermined time, because I would imagine most people want to use these as 4 independent switches. Certainly that's the way I want to go. Now, regarding software, what I'm thinking of is, and going back to my previous video on this subject, I said this was going to provide one part of the overall solution, so this won't be switching mains to that heater. What I'm actually going to do, I'm just going to take myself off picture here so that my head doesn't get in the way. Right, so what I'm expecting to have then is this unit as an input to the whole solution, but generally I'm going to have in the middle a Pi of some kind. On that I'm going to run a message broker, MQTT, or at least try to, Mosquito probably, because I think that is, well, if it's not pre-installed on Pi, it's certainly easy to install it. Also Node-RED is pre-installed on Pi. Now, Node-RED, in case you aren't aware of it, is a visual programming application that lets you, well, create nodes and things. In fact, going back to the beginning of this video a little bit, where we looked at the MIT App Inventor, or referred to it, it's a bit like that. So you can draw diagrams and it creates some JavaScript, I think, at the end of the day. So you could write it natively if you really wanted to, or use Node-RED. It's just a programming aid at the end of the day, and it deals with events. What happens, you know, if this then that type of thing, as far as I can work out at the moment. The message queue broker basically is going to, what I want to happen is that we send in messages via Wi-Fi, of course, not any other way. So all this is going to be connected to Wi-Fi, as is this, of course. So we'll draw a little thing there. So that's already connected to Wi-Fi. So this is going to talk to this, via one of these, and I'm not quite sure how, whether it's going to be hard coded or whatever. But anyway, the message queue broker says, oh, I've received this message. I wonder if anybody's interested in receiving that message. And other things may be connected to here. So a receiving unit may be here, or indeed it might be directly on the Pi itself. But basically, this could receive and send via Wi-Fi again a message to which it is subscribed. So basically what happens is lots of messages can be sent to the Pi. MQTT simply acts as a broker, a middleman. It collects all the messages, find out what topic they're going to be associated with, and send them out again to various devices like this, who decide whether or not they really want them. Now I know it's all a bit vague at the moment, mainly because, well, my understanding isn't quite that vague, but certainly I've got nothing working yet on here. In my day job we use message queuing as well. We have topics and stuff, message buses basically, and put messages on there and something listens for them and acts upon it. Interesting enough, if, for example, the receiving unit were out of action for a little bit, but the sending unit, whatever it is over here that's sending a message, isn't out of action, so it sends a message to Pi, the message queue broker jumps in and says, oh yes, I understand what you've sent me, I'll resend it or do whatever, it's process it basically. What's it going to do if this unit for some reason then is offline? It might only be offline for a few minutes. We really would like this to act upon that message when it comes back online. So as I say, in my real job there's a time to live on a message, which might be something like 2 hours, could be 24 hours, you determine that. But I would like that to be, if at all possible, I'd like that to happen on here as well. But we'll wait and see. I'm hoping, of course, nothing does go offline, but you could never be too sure, can you? So that's the general idea. So one of these inputs here for the Amazon Echo controlled heater will be do something, and the heater will be controlled somewhere on here. And the other three outputs might be lighting, could be my new fan that you can just see over the top of my head. Look, if you look up where the pen's sort of pointing there, there's a new fan on my workshop blowing the hot air from the heater across the roof and down to me here. Makes it much more efficient. So that could be one, for example. So lighting, fan, and I don't know, something else. Something will come up, I'm sure. So that's the general where I'm heading. Let's see how far I get over the next couple of weeks, and I'll do another video. Might not be the next couple of weeks actually, because there might be something else coming in the meantime. I've got a couple of other items from China, and let's hope they're made a little bit better. At least somebody's tested them, because all these things that don't work. Okay, let's calm. Right, I think we'll call a halt there, because this video is already getting a bit long. So if you've got any experience of this, now I know that there've been a few suggestions already about using Node-RED or MQTT or Tasmotor or whatever it is we're going to run on the Pi. Fine, put those on there, because I'd like to read up about it and then make a decision really and start experimenting. Okay, that would be really useful if you can do that. Otherwise I'll read up lots of stuff and come back to you next time. Good, well I hope you found the video instructional and informative today, not least about the poor state of some of the Chinese components. But then again, you know, this is made in China, isn't it? It's very nice quality indeed. And in fact, just on a safety aspect, just before I go, if you've noticed, all these slots that are cut into the board now around all the mains type of stuff, slots here, look, all between the actual mains things over here, basically trying to separate all the mains bits from everything else, and indeed even between mains, because this is say the common one here, so that might be live, that's normally open, that's normally closed, so even between these there's this nice gap. So yeah, that's they've obviously thought about this quite long and hard, and it's a nicely constructed board. So that's Sonoff for you. Good, okay, we'll leave it there, and thanks for watching. Please do leave comments below, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.